All right, we're ready to start our first little video series here with compounds, molecules that do not contain hydrogen atoms in their formula. So the first one we're going to look at is CCl4. I've written the name over here, carbon tetrachloride, because in the next lesson or two we're probably going to be talking about how to name these compounds. So we need to be able to do that. All right, so let's think through our steps here. The first step was to work out the NASB numbers for our compound. So we're going to try to do that here. Let's look at this. Needed. The first step would be to look at that compound and see if any hydrogen's in there, and we say no. Okay, so we know that every atom in there, for our purposes, will need 8 electrons to be happy. So how many atoms do we see in that compound? We see 5, is that right? We see 1 carbon. We just don't write it there. The fact that we've written the symbol for carbon says there's 1 there. And we see 4 chlorines. So I see 5 atoms, each of which needs 8 electrons. So if I do that math, 5 times 8 is 40 electrons are needed. All right, 40 are needed. All right. Available. If you remember what we said about available electrons, those were the electrons in the valence shell for each atom, and for our purposes that's really kind of looking at the group number, because the group number is going to tell us how many valence electrons each of those atoms is going to bring to the bonding party here. So the way we would do that is we'd say, okay, I have 1 carbon atom. Now if I hadn't already said this, you need your periodic table so you can be following along and finding the right number of valence electrons here. 1 carbon, and if it didn't move position, it's sitting in group 4, so it's bringing 4 electrons. And to that, we're going to add the 4 chlorines. The chlorines are in group 7, so they're bringing 7 valence electrons. All right. So let's do the math there. 4 times 7 is 28, and 4 more is 32, so we have 32 electrons available. All right, now here is a place to make a check. For the compounds we're drawing, needed should always be larger than available. If it's not, you've made a mistake somewhere. You can't multiply or add correctly, or both. And they should both be even numbers. We've kind of talked about that before. If you looked at video 3B, we did talk about that. Okay, because needed is only some number times 8 or some number times 2, and all of those multiplications are going to end up with even numbers. All right. Available should also be even, because shared, all right, it's going to be N minus A, if you remember. So we're going to take 40 and subtract 32 from it, and we're going to find out that 8 electrons have to be shared. All right. That has to be shared. And we know shared has to be an even number, because the bonds, to find the bonds, we're going to take the number of shared electrons and divide it by 2, because it takes 2 electrons for every bond. So we're going to take 8, divide it by 2, and say that in our structure we need to show 4 bonds. All right, we need to show 4 bonds. All right, the next thing we want to do then is figure out our central atom. Remember how we're doing that? We're going to go back and look at what's the least electronegative element in that compound. So you need your periodic table, and you need to remember your electronegativity trend. Essentially, if you look at it, carbon is really farther away from fluorine than chlorine is. So for one thing, carbon is less electronegative. The other is carbon always likes to be in the center, so that's another reason it might be the central atom. And the third reason is it's the only one of its kind in that structure. I've got 1 carbon and 4 chlorines, so carbon is probably the central atom. So I'm just going to change pen colors here for a minute. So central atom is carbon. So we're going to come over here. All right. The next step 1 was to do that, the NASB. Step 2 was to choose the central atom and write it down. Step 3 was put all of the other atoms around that central atom in some symmetrical pattern. So I'm going to put a chlorine top, left, bottom, and right. Okay, so that's my symmetrical pattern. The next step was to draw a single bond to each of those, right? Without even doing anything else. As soon as I put them there, I draw a single bond. All right, now, we need to make this check. I have used 4 single bonds. The structure said I needed to use 4 as a minimum, so I've got the right number, so I'm okay. All right, and then the next step is what? Assign the available electrons. So I've got 32 available. Do not go back to needed. Go to available. I've got to assign 32 electrons to this structure. I need to start on the outside elements because they're the more electronegative. I need to assign them 8 electrons. Since there's no hydrogen, everybody wants 8 electrons. All right, so the chlorine here at the top already has 2 electrons right there in that bond. So it needs 6 more. So I'm going to put electrons assigned in pairs. All right, that's 6. This chlorine already has 2 here, so it needs 6 more. This chlorine already has 2, so it needs 6 more. That's not very good. There we go. This one obviously needs 6 more also, so we're going to do that. All right. Now, I've assigned 8 electrons to everybody on the outside, so let's see how many I've used. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. I have used 32. I needed to use 32. Looks like I might be done. Our really last check is to check to make sure every atom in there has 8 electrons. We just counted the chlorines. We know they have 8 electrons. All right? We know they have 8 electrons. How about the carbon? Yep. It's got 2 right there, 2 more there, 2 more there, and 2 more in that last bond. Remember, so 2, 4, 6, 8. The carbon has 8. The electrons in the bonds count as 2 electrons to each atom in that bond. So everybody has 8 electrons, and we are happy. We've used all of our bonds. We've assigned all 32 electrons, and everybody that needed 8 has 8. All right, everybody feeling good about that? All right, here's what I want you to do. I want you to do a Lewis dot structure for SiBr4. All right, SiBr4. Or I got kind of messed up. SiBr4. I want you to put this on pause, draw your structure, then bring it back up and click on the next slide. All right, that's what I'm going to do. Go through all your steps. NASB, right here, central atom, put it in there. Assign the bromines. Oops, kind of gave away what the central atom is. Assign the other atoms to the outside. Go back and check your available number and assign octets, and then double check everything. All right, go ahead and do that. All right, hopefully you've gotten that done. You've drawn your structure for silicon tetrabromide. All right. Hopefully when you did your NASB count, N came up to be 40 again because you had 5 different atoms, 1 silicon and 4 bromines. Everybody needed 8. There were no hydrogens in there. When you did your available count, you got 32. Because why? Silicon is in group 4 and each of the bromines is in group 7. All right. You did your shared. You took 40 minus 32 and got 8. And to do bonds, you took 8 and divided by 2 and got 4 bonds. Hopefully you chose silicon as your central atom. Electronegativity-wise, in the periodic table, to me it looks like it's a little farther away from fluorine than bromine is. The other reason is it's the only one of its kind. I got 1 silicon and 4 bromines in there, so I went ahead and put the silicon in the center. I arrayed the 4 bromines around it in a symmetrical pattern, top, bottom, left, and right. And I went back to assign 32 electrons, starting with the outside bromines first. And each of them needed 6 more because I had 2 from the bonds. Okay. I guess I skipped over that step. As soon as I assigned the silicon and as soon as I put the bromines out there, I drew a single bond to each of them. Made sure I had 4 bonds and assigned them. And then I went back and assigned my 32 electrons to everybody on the outside. And when I did that and did my count, I found out that all 32 had been assigned. And I checked my structure. Each bromine had 8. And the silicon had 2, 4, 2, 4, 6, and 8. So everybody was happy. So this is a good full credit structure if you have to draw that on some future exercise. That'd be a good picture of silicon tetrabromide. All right, that ends this one. If you didn't have any problem, that's good. You're on your way. You can look at the next ones as you need to. We're going to go ahead and do that whole series. So if you've gotten this, you're off to a good start. The more practice you get, I think the better off you are. But again, I think it goes back to memorizing and following in order those steps for the NASB method. All right, that ends this one.